So yeah, my class. Today we want to solve this question on the analysis of variance. Here, our interest is centered in the effect of tube conductivity. So we have the data set on the TV tube coating data, which is treatment 1, 2, 3, and 4. So the first question here says that suggest the experiments to use. Now looking at this, since our interest is on the TV tube coating data, okay, we just want to see if there's significant difference in the mean of the tube coating data. So for the first question being asked here, so we're going to use what is known as this is a complete randomized design. And if you ask me why, here there's nothing like blocking, so we are not doing any blocking. So other way known as one-way ANOVA. So this is the one-way analysis of variance. So the second question is that write down the mathematical model for this. So writing down the mathematical model, you can check some of my previous videos for the proof of this model, how the model is being gotten, the breakdown, the composition of the one-way ANOVA. I have it. You can, at the end of this video, I'm going to attach it to it. So having this, the model for the CRD will be Yij equals mu plus tau I, which is the treatment, plus the error term, which is the Eij. Don't forget that my I is from 1 to 5 and my J is 1 to 4. So we have J 1 to 4 and I, the rows, is 5. And before I proceed with this, there's a need for me to talk about the constraint. So we talk about the constraint. So the constraint we have is that our summation of tau I, where I is from 1 to 5, must be equals to 0. That's the general constraint that we have. And talking about the distribution of our error term is normally distributed with mu and variance sigma square. So the third question is to analyze the experiment and comment on the result. So this is the analysis of the experiment. So doing the analysis of the experiment here, for one-way ANOVA, the general formula for the one-way ANOVA, the first thing you need to calculate is the sum of square total, which is known as SST0, which is double sum your Yij squared minus y dot dot squared over capital N. Here, my y dot dot over capital N is known as the correction factor. If you check my previous video on one-way ANOVA, you're going to see how I got this, the general formula for the SS total. You can check my video. So now, calculating this, there's a need for us to know the grand mean and the grand total, which is y dot dot. So here, I'm going to have yi dot. That is the sum of the rows. The sum of the rows. Okay? So this is the treatment. So here, summing this row-wisely, I'm going to have 207. That is 56 plus 64 plus 45 plus 42 is going to give me 207. And for the second line, I'm going to have, you can use a calculator to confirm these values, 201. And thirdly, I'm going to have 202. Then I'm having 196. And here, I'm going to have 200. So here, yi dot bar. So my yi dot bar can be calculated by making this 207 divided by the total. Okay, the total here, which is 4. So 207 divided by 4 is going to give me 51.75. 201 divided by 4 is going to give me 50.25. And 202 divided by 4 is going to give me 50.5. 196 over 4 is going to give me 49.0. And lastly here I'm going to have 50.0. So y dot dot, which is the grand total here, summing these together, this column together, I'm going to have 1006. And for the grand mean, which is y dot dot bar, is going to give me 50.3. That is calculating the average of this column. Now coming back to my sum of square total, my summation yij all squared is just going to be here. What do I mean by summation yij all squared? It means that we are summing each of these observations, that is 56 squared plus 64 squared, up to the last observation, which is 41 squared. So here I'm having 56 squared plus 64 squared up to the last individual observation, which is 41 squared, minus y dot dot, which is 1006 squared, over capital N. Then how do we determine our capital N? Now coming here, we have that our A equals to 5 and my N is 4. So my A is 5, calculating the 1, 2, 3, 4, 5. My N is 1, 2, 3, 4. So with that, my capital N is the same thing as 5 times 4, which is 8 times N, which is 20. So here, using that, I have my capital N to be 20. So summing up the observation, here I'm going to have 51,940 minus the correction factor. 1006 squared over 20 gives 50,601.8. Subsequently, this is what I'm going to use for my correction factor. So my SS total gives 1,338.2. That is my SS total. So after that, there's a need for me to calculate my sum of square error. Don't forget the formula. The formula says that SS total equals to SS error plus SS treatments. So I've calculated my SS total. There's a need for me to calculate my SS treatment. So calculating my SS treatment, which is SS treatment equal, I'm going to use two formulas here, but the first formula is double summation y I dot bar minus the grand mean squared. So using this formula, we're going to have yi dot minus y dot dot. Looking at my yi dot here, the first one is 51.75. Here I'm having 51.75 minus y dot dot bar squared, which is the grand mean, 50.3 all squared, plus up to the last mean. My last mean here is 50.0. So I'm having 50.0 minus 50.3 all squared. So summing this over, here, don't forget that I'm having double sum. So the first one is summing to n. So I'm having n multiplied by all this. And don't forget my n, the value of my n is 4. So multiplying this with the sum in the parentheses, I'm going to have 3.925. That is the sum of the parentheses. And this gives 15.7. So that is my SS treatment. So having gotten my SS treatment, I can easily get my SS total, SS error. My SS error from here will be equals to SS total minus SS treatment. And that's going to be SS total, which is 1338.2 minus 15.7. My SS error is going to be 1322.5. Yeah, before I proceed, like I said earlier on, there's an alternative way of calculating SS treatments. And then the alternative approach for calculating SS treatments is using this formula, which is SS treatment equals to 1 over n summation yi dot squared minus the correction factor. And this is just going to be 1 over n, which is 1 over 4, yi dot squared. Looking up here, my I dot is 207 for the first one, 201 for the second one, up to 200. So this is just like having 207 squared plus 201 squared, and to the last one, which is 200 minus the correction factor. So here, I'm going to have 1 over 4 multiplied by 202,470 minus the correction factor, which is 50,601.8. So finally here, I'm going to have 15.7, which is the same thing as the previous one we've gotten. So now we've calculated our SSC, SSR. Let me just write it out again. Here, my SSE is 1322.5. SS total is 1338.2. SS treatment 15.7. So with that, we can easily calculate our mean square error. So here, the formula for calculating my MSE, which is the mean square error, is the SSE over the degree of freedom of the SSE, and that is n minus a. Like I said earlier, you can check my previous video to see how I got this. Here I got 1322.5 over capital N is 20 minus our A, which is 5, and this gives 88.17. Secondly, we have the MS treatment, which is SS treatment over the degree of freedom, which is A minus 1. And my SS treatment is 15.7 over 15 minus 1, which is 5 minus 1, which is 4. So this gives 3.925. So to calculate my F, the formula for calculating F is MS treatment, in this regard, we are no longer using our SS total over mean square error. So my mean square treatment, which is 3.925 over mean square error, which is 88.17, gives 0.445. So using your calculator, you can check your F table. If you want to check your F table, you're going to use F. You're at 0.05. You can check that, okay, which is 0.95, comma mean square error for the treatment, which is 4, comma mean square error for the error, sorry, the degree of freedom of treatment and the degree of freedom of error, which is 15. So what you have, compare it. But here I'm going to use p-value. My p-value, I use my calculator to get my p-value, happens to be 0.774. So lastly, for my comments with this, my comment is just going to be like comparing, using p-value to make conclusion. Since the p-value is greater than 0.05, which is our alpha level, okay, hence we do not reject the null hypothesis. Then you're going to ask, I didn't state any hypothesis. The hypothesis has been explained at the beginning of the class, which is what we are working on, that there's no significant difference in the effects on tube conductivity. So we reject the null hypothesis and conclude that there is no significant difference in the 4 types of coating of TV tubes. Thank you very much for watching. And before I leave, please just know that here you can be asked to calculate the LSD, which is the least square difference, to know which one is significant. Since there is no significant difference, then you can calculate LSD. Thank you very much for watching my video. Please kindly subscribe to my channel. See you next time. Thank you.